we want to examine the calculations in stoichiometry. We want to continue our class on stoichiometry. Anything that happens to the reactant, we want to see the effect on the product, and it must happen simultaneously. So we have how many moles of JAM 2000 question 5. How many moles of HCl will be required to react with potassium heptadichromate 6 to produce 3 moles of chlorine? And we are giving all the options. This is a chemical equation that we call which happen majorly in redox reaction because of the heptadichromate 6. It's a very powerful reagent. So we want to see what happens here. It says how many moles of HCl, JAM 2000 question 5. So we have, we're required to react with potassium heptadichromate 6. How do we write that? We have K2Cr2O7. How did I get this? Chromate ion. This is chromate ion. Cr2O7, 2 minus. This is how to write chromate ion with potassium. So that's why potassium is having 2 as the atom. So potassium chromate reacting with HCl gives. So how do we know the reactant and the product? Potassium will react with chlorine. Chromium will also react with chlorine. But the chromium here has oxidation number of 6. But once it's coming to the product, it will change to 3, telling us that it has undergo reduction. So let's start that. Potassium with chlorine, we have potassium chloride. Reacting with chromium with chlorine, that's chromium 3 chloride. We now have oxygen and hydrogen, gives water, and we are told it will liberate chlorine. So we have chlorine. Chlorine is diatomic, that's why it's having 2. So let's balance the equation. Potassium is having 2 moles of potassium. This is 2 atoms of potassium, 1 atom here. We have 2 here. We have chromium is having 2 atoms here. There is only 1 atom. So how do we balance it? We put 2 moles. We have oxygen here is 7. Oxygen here is 1. We put 7 here. You can see that the total numbers of hydrogen here is 14. But the total number of moles of hydrogen here is just 1. So we put 14. But let's see the chlorine. Chlorine is having total number of moles of 14. 14 moles. Let's see the total number of moles of chlorine. That will give 3 moles of chlorine. So we put 3 moles of chlorine here. So let's see them. 2 times 3. That's the 6 plus 2. That is 8. 2 times 3, 6. 8 plus 6 will give you 14. So the total number of moles of chlorine is 14 at the reactant, 14 at the product. So how many moles of HCl will be required to produce 3 moles of chlorine? So it's 14 moles. So this is option A. I hope you have gained something in this video. See you in my next video. Bye.